To illustrate the value proposition for lore, we're going to start by building up a raw Redux application. Here we have an application that allows people to post content to various social media platforms. And what we want to do is create a post. So the first thing we're going to do is create an action for creating a post. When invoked, this action creator will make a request to the server and send along the data that represents the post. The API server will create the post and send a response back containing the JSON that describes the post that was just created. The action creator will take this response, marshal it into an action, and dispatch that action to the Redux store. The store will in turn give each of the reducers a chance to do something with the response. So at this point, we also need a set of reducers. Since reducers represent the state of our application and the data structure that the components interact with, we frequently will create multiple reducers that store the data in a way that is meaningful for our needs. In this case, we've created a reducer that keeps track of our posts by ID, another that groups them by user, and a third that maintains a list of all posts retrieved. Once our reducers are done processing the action, our store's state updates and the application is notified. This in turn causes the application to re-render our components, and our new post appears within our application. This is a pretty typical interaction between actions and a set of reducers. So to illustrate the value proposition for lore, let's take a look for a minute at just the actions and reducers. So here we've got the actions on the left and the reducers on the right. And these were both created in order to interact with a post model. But in this example, we only had one action for creating a post. In reality, we'll frequently have a set of actions for every model so that we can create, update, delete, get specific posts, as well as an action for retrieving a collection of posts. Now, if we were to add a second model to view comments associated with posts, then we would also need to generate another set of actions and reducers in order to provide full CRUD support for comments, so that we can create them and edit them as well. So in this example, with two models, we have 10 actions and 6 reducers. But considering that it's not uncommon for larger applications to have 10 or 20 or 30 endpoints, it doesn't take much before we have dozens upon dozens of actions and reducers. So how does lore help? And the answer to that is that it takes a page from server-side frameworks and uses conventions. So here we have a beginning lore project. We have folders for our actions and reducers, but they are currently both empty because we don't have any. And just like before, we have this post model, and we need to be able to create a post. In lore, you do that quite literally, and you create a file called post in the models folder. This file is empty. It's the name that's important right now. And through conventions, recognizing the recurring patterns that naturally exist within actions and reducers, this empty file actually implies the existence of a full set of actions and reducers that support standard CRUD operations. So what do I mean by that? Let's use this component as an example. Here we have a React component that has a form, and the user is going to fill that out, and when they submit the form, we want to extract the title and create a post from it. To do that, we don't need to create an action, we just need to call it. Lore is the name of the framework, but it's also the name of a variable that all components have access to. And this variable hangs a lot of really useful things off of it, one of which are the application's actions. And every time you create a model, Lore appends the name of that model to actions and automatically fills it out with a full set of action creators for standard CRUD operations. These actions are derived from blueprints within lore that take advantage of the natural patterns in actions and reducers that we mentioned previously. We'll continue this example to illustrate. Since we're trying to create a post for this example, we'll do just that. So here we've called lore.actions.post.create and passed it an object with the data that we want to send to the server. So let's focus on that for just a minute. Here we're looking at just the call to create a post. When we make this call, lore will automatically send out an AJAX request to the server, which we specify elsewhere in the application and pass along the data that we provided. In addition to the blueprint for a create action, lore also provides a blueprint for the update action that will make a put request to update a resource, a delete action that will send a delete request to destroy a resource, a get blueprint to retrieve a specific resource, and a find blueprint to retrieve a collection of resources or perform a search against an API endpoint. So to recap, the creation of a post model implies by default the existence of create, update, and destroy actions, as well as get and find actions. And the reason that we've broken out the get and find actions is because they deserve a little more attention. Instead of calling these actions directly, the more common usage is handled by the framework itself, as it allows components to declare the data they need directly. To illustrate, we're going to take a look at this component. This component is responsible for rendering a list of posts, and to do that, it needs a set of posts to render. So how do we get our set of posts into this component? And for that matter, how do we fetch the list of posts from the server? Well, both of these questions are answered by a decorator that Lore provides. So this component is an ES5 component, and what we're going to do is we're going to move it down, and we're going to decorate it with the lore.connect decorator, and indent it for readability. So here we have an ES5 version of a decorated component, but for these examples, it's a little easier to read the ESNext style, the upcoming version of ECMAScript. So we're going to quickly refactor. So we'll remove our indentation and convert our React component to ES6 and our decorator to the ESNext style. And for now, we'll just focus on the decorator. So this syntax inside the decorator is pretty minimal, but it actually does quite a bit, and it's easiest to think of it as a question and a command. The question is this: has the post.find reducer set a value in the store's state? Now remember that at this point, we haven't created any actions or reducers explicitly, but that the existence of this model implies support for CRUD operations, and that includes a set of reducers. So when we ask about the post.find reducer, we're referring to this reducer that was created by a blueprint. And as a Redux refresher, a reducer structure like this will typically compose a store state structure like this, where the folder structure mirrors the object structure. So when we ask whether the post.find reducer has set a value in state, we're really looking to see if state.post.find has a value that is not the initial default. So back to the question. If the answer to the question is yes, this decorator will extract that data from state and pass it into the component as props. If the answer is no, and this is where some of the magic in Lore really starts to happen, it will automatically call the action responsible for retrieving that data. And once the application has the data, the store will update, the master component at the root of the application will get notified, and the application will re-render. In other words, this is that same interaction in comic form. Our decorated component on the left says, "Yo, I need all the posts we have. Give me everything in state.post.find." And Lore says, "Hello, it looks like we haven't fetched any posts yet." And the decorated component says, "Then go get them, please." And Lore says, "Okay, retrieving them now." Off it goes to get them, and the component says, "Thank you." All right, so now that we understand the concept, let's walk through some of the typical questions we might want to ask inside this decorator. The first is the example we just covered, to retrieve a collection of posts. So if we ask for post.find, and we haven't fetched any posts yet, then Lore will execute the post.find action, which will make an AJAX request to retrieve the collection of posts. If instead what we want is a subset of the posts, we can pass in a where clause, which will get passed to the action and become a network request to search the post's endpoint. We can also request a post by ID, a common usage of which would be to retrieve data associated with a specific route, such as the post corresponding to the post ID in a URL, which is provided to us by React Router. So to recap what all of this means, if we go back to our project structure, we have a single post model. And the existence of this model implies the existence of a default set of actions and reducers to support standard CRUD operations. If we need to interact with another resource, such as comments, then we simply add a model called comment. And Lore will in turn generate a series of actions and reducers to support standard CRUD operations on comments. So that's all fine and dandy, and it's nice to get things for free as it allows you to focus solely on your components. But conventions fall apart when servers don't have conventions themselves. So what happens if you have an endpoint that Lore's conventions can't map to? And in that case, you just override Lore's default behaviors. To illustrate, let's say we need to customize the create action for a post. To do that, we simply create our own action under actions/post/create. Once we do, Lore will notice that we've created our own create action for post, and it will use that one instead of the default. Reducers follow a similar pattern, and you can also create your own actions and reducers to extend those provided by the framework. For example, if you were to create a custom reducer under reducers/post/custom, replacing custom with whatever you actually wanted to call the reducer, Lore will pick it up and add it to the list of available reducers for post. To recap how Lore helps with Redux, Lore uses conventions to automatically provide a full set of actions and reducers for any models, which you can then override as you need to. Lore also has a decorator that allows components to declare the data they need, which is then lazy loaded on demand. Now, while we didn't talk about this point, all of this is in fact highly configurable, and Lore is capable of interacting with multiple API servers and can change many settings on a per model basis. In summarizing all of that, Lore basically allows you to ignore Redux until the needs of your application demand that you can't.